Hello, and today we're going to learn the specific heat of two different metals. The metals being copper, which is going to exist in this kind of clumpy form, just little hunks of copper, and also aluminum, which I have much bigger pieces of. I'm not going to lie, this is a lab you're probably going to be happy with doing online, because this is a very long lab, though I won't film the entire process, because it involves waiting for water to boil. But what we're going to do today is we're going to find the specific heat of these two metals doing something called calorimetry. Calorimetry is a process using a calorimeter, which is this right here. What a calorimeter is it's a cup hanging by something that's non-conductive, sitting inside a bigger cup, so that the two surfaces aren't touching. What this does is it creates a cup that has minimal heat loss. You see, because there's a bed of air between the inner cup and the outer cup, heat won't really be lost to the outside. And what I'm going to do is I'm going to mix a hot metal and a cold water. And I'm going to mix them and let them come to thermal equilibrium, aka make it so they become the same temperature. Once they become the same temperature, I'm going to find out how much heat did the water gain when it heated up, how much heat did the metal lose, and also how much heat did the calorimeter gain itself, because this cup is also going to heat up a little bit. And we can use all these calculations to try to find exactly the specific heat of the metal. Now, I'm going to walk you through the process, and today I'm going to give some of how to analyze it in this video. So it's good thing you're watching it. I say you should go watch it, but you're already watching it, aren't you? So here's how it's going to work. I'm going to take this cup and I'm going to fill it about a third of the way with water. Just going to have to trust me how far I filled it. Now this cup is aluminum. I'm going to keep that in mind. And then I'm going to go and figure out, actually skip a step. I'm going to go figure out the mass of this. Now actually I should have waited beforehand. I want to know the mass of this cup empty, which I will give you. And I also want to know the mass of this cup with water in it. And from that I can get the mass of the cup and the mass of water. I'm going to need both. What I'll then do is I'll put this on its little hanging hook. I will put that in here. And I'll put that in there. Meanwhile, I'm going to take this guy, and what I'm going to do with this is I'm going to put some metal in it, and I'm starting with copper for some reason. And I'm going to go weigh out exactly how much copper I added. Now obviously I didn't just do that here, but when I actually took the data I did. Once I know exactly how much copper I have, I'm going to put this in here, put that there, and turn on this hot plate. This big bronze thing, this big copper thing is filled with water. And this down here is a hot plate. What I'm going to do is I'm going to heat it up till that water is boiling. When that water is boiling, that's going to heat up the copper. And it's going to heat up to about 90 degrees Celsius. Meanwhile, I can find what temperature my water was. That was room temperature, around 20-ish degrees Celsius. Once that's boiling, what I'm going to do is I'm going to take my hot copper at about 90 degrees Celsius, that I know the mass of, and my cold water, about 20 degrees Celsius, and I'm going to take this, pull that out, and dump that right into the water. Once I dump it into the water, I can use this rod to store, and what's going to happen is this temperature is going to start going up. The water temperature is going to go up because it's getting heated by the copper. While that water temperature goes up, the copper temperature is going to go down, and eventually they'll hit thermal equilibrium, aka they'll both be the same temperature. Once they're both the same temperature, I'll record that value. You see, I can find the heat that the water gained. The heat the water gained is going to be the mass of the water, specific heat of water, which is known, times the change in temperature of the water. What it ended up being minus what it started out at. What it ended up being this final. I can also figure out how much heat the calorimeter got. The mass of the cup, C of the cup, which is aluminum, so I'll use the value of aluminum, the change in temperature. Now that'll tell me how much heat the water gained and how much heat the cup gained. And if I take those two values and add them together, that's the total heat gained by the system. But conservation of energy says you can never get heat from nowhere or energy from nowhere. And what that means is however much heat that gained, that's how much heat the metal lost. And therefore the heat of the metal would just be the sum of those two values. I can then take the heat of the metal and use that MC delta T and rearrange and solve for C, solve for the specific heat of the metal. And that's what you're going to be doing today.